Hey everyone, and welcome back to The Explainer. Today we're diving into a function that secretly runs the world all around us. We're talking construction, design, even just how your brain processes steepness. It's called the tangent, and trust me, it's about to completely change how you look at triangles. Let's get right into it.
So, I want to start with a kind of a wild question. In a right triangle, we always focus on the hypotenuse, don't we? It's the longest side. It's the star of the Pythagorean theorem. But what if I told you that to measure the true steepness of an angle, that super important side was, well, totally irrelevant?
Think about the first two trig functions you probably learned, sine and cosine. Both of them are completely tethered to the hypotenuse. Because you're always dividing a shorter side by the longest side, the answer you get for sine or cosine can never be bigger than 1. They're kind of locked in, They've got a ceiling.
And that's where our hero of the day comes in, the tangent function. It's the rebel of the group. It just completely cuts the hypotenuse out of the picture. And by doing that, it doesn't just measure some ratio inside the triangle. No, it measures pure, raw, unbounded steepness. No limits.
So how on earth does it do this? Well, here's the brilliant part. You already know the core concept. You learned it back in your algebra days. We're just giving it a brand new trig-friendly name. So here's the official definition. The tangent of an angle, which we just shortened to tan, is the length of the side opposite the angle divided by the length of the side adjacent to the angle. That's it. Simple as that. No hypotenuse in sight. And this is where it all just clicks, right? The opposite side, that's your vertical rise. The adjacent side, that's your horizontal run. So when we say opposite over adjacent, all we're really doing is calculating the slope of the hypotenuse. It's the exact same idea, just wearing a different hat. And this is what's so cool about taking off that leash. You could have a super tall, skinny triangle with an opposite side of 50 and an adjacent side of 1. What's its tangent? Boom, 50. Or a long, really flat triangle could have a tangent of, say, 0.01. Because that hypotenuse is gone, the tangent isn't stuck below 1 anymore. It can be any positive number you can think of, which makes it so versatile. Okay, enough with the theory. The best way to really get this is to see it work. So let's roll up our sleeves and walk through 3 examples, going from basic to a bit more advanced to really make this stick. First up, a classic. We've got our good old 3-4-5 right triangle. And for a certain angle, let's call it angle A, we're told the side opposite it is 3, and the side adjacent to it is 4. Our job is simple. Find the tangent of A. Okay, the only thing we need to do here is follow the formula. We're looking from the perspective of angle A. The opposite side is 3, the adjacent side is 4. And that hypotenuse, the side with a length of 5, we literally just throw it away. We don't need it. So the tangent of A is simply opposite over adjacent, which is 3 over 4. Done. All right, next up, a really cool special case, an isosceles right triangle. That's the one with 2 equal sides and 2 equal angles. In this one, both of the legs have a length of 7. So what's the tangent of a 45-degree angle? Let's see how this plays out. You can pick either one of the 45-degree angles. It doesn't matter. From its perspective, the opposite side is 7, and the adjacent side is also 7. So the tangent is 7 divided by 7, which of course simplifies to exactly 1. And that makes perfect sense, doesn't it? A tangent of 1 is a slope of 1. It means for every step you take forward, you take 1 step up. You're rising exactly as fast as you're running, giving you that perfect 45-degree angle. Okay, time to ramp it up a notch. This time, we're going to work backwards. I'm not giving you a triangle. I'm just telling you that the tangent of some mystery angle is 3/4. From that one piece of information, can you actually figure out the sine of that same angle? You bet we can. Look, since we know tangent is just opposite over adjacent, we can literally sketch a triangle that fits that ratio. We'll just say the opposite side is 3 and the adjacent side is 4. Now, to find sine, we do need the hypotenuse. So we bring our old friend the Pythagorean theorem back into the game. 3 squared plus 4 squared equals the hypotenuse squared. Well, 3 squared is 9, 4 squared is 16, add them together and you get 25. And of course, the square root of 25 gives us our missing piece. The hypotenuse has to be 5. See that? The tangent gave us the blueprint to build the entire triangle from scratch. And just like that, we have all 3 sides, so finding the sine, that's the easy part now. Sine is opposite over hypotenuse. Our opposite side is 3, and the hypotenuse we just found is 5. So the sine of our mystery angle is 3/5. Fantastic.
So far, we've kind of been treating triangles like these little physical objects, where lengths are always positive. But the real power of trigonometry is when you put these ideas onto a coordinate grid. So what happens when we leave the safety of the paper?
This leads to a really important question. Since we've already established that tangent is basically just a fancy word for slope, can the tangent, this thing we're calling slope, actually be a negative number?
Oh, absolutely. Once you're on the coordinate plane, you stop thinking about lengths and you start thinking in x and y coordinates. The opposite side lines up with your y value, your rise. The adjacent side lines up with your x value, your run. And just like in algebra class, if you have a downward rise that's a negative y, or a leftward run, a negative x, you can totally get a negative slope, which means, you guessed it, a negative tangent.
All right, to wrap things up, let me show you one of my all-time favorite real-world examples where the tangent function is hiding right out in plain sight. If you've ever been near a construction site or looked at blueprints, you might hear a phrase like this. An architect says something like, "The specs call for a standard 412 pitch." Sounds like some super technical industry jargon, right?
Yeah, it's not pitch is literally just the tangent. A 412 pitch means the roof needs to rise 4 inches for every 12 inches it runs horizontally. Rise over run, opposite over adjacent. The architect is basically just handing the builder the tangent ratio, and the builder uses that slope to frame the whole roof. It is a perfect, practical, everyday use of this function.
So here's the big takeaway. Tangent isn't just some abstract formula in a math book. It's the language we use for steepness, for slope, for pitch. You'll see it in the grade of a road you're driving on, the design of a wheelchair ramp, the rafters holding up a roof. So I'll leave you with this question. Now that you're in on the secret of slope, where else are you going to spot it? Thanks for watching.